This is SpaceTime Series 25, Episode 100. Coming up on SpaceTime, counting down to asteroid collision. A new study shows how continental plate movements control Earth's largest volcanic events. And China launches more spy satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Double Asteroid Redirection Test, or DART mission, remains on target to crash into a potentially hazardous near-Earth asteroid on Monday. The cosmic collision is part of a planetary defense exercise trying to determine what to do if astronomers discover a large asteroid on a collision course with the Earth. The 610-kilogram DART spacecraft will slam into its target, the 170-metre wide asteroid Dimorphos, at 6.6 kilometres per second. The impact will take place at approximately 7:14 p.m. US Eastern Standard Time on the evening of September the 26th. That's 9:14 the next morning, Australian Eastern Standard Time. The massive impact should not only create a huge crater on the asteroid surface, but also slightly change its orbit in space. Dimorphos is orbiting the larger 780-metre wide asteroid 65803 Didymos, and the impact should push Dimorphos several metres closer to Didymos, possibly even slightly changing the trajectory of both bodies. Jonathan Alley, the editor of Australian Sky and Telescope magazine, says the impact will provide scientists with important details about the composition of these Earth-crossing asteroids known as Apollos.
It's going to be very interesting to see what happens. They're pretty certain they know what's going to happen. And, of course, there's no danger to anyone. It's not going to send anything flying towards us. But the important thing about planetary defence, you just mentioned, and these asteroids and things, is that if you're going to defend against something, you really have to know your enemy. And go back some years, and it was probably widely thought, if not completely mostly thought, that an asteroid was just like a huge solid chunk of rock. But now we know that many of them, some of them at least, and possibly many of them, are actually rubble piles. They're sort of bits of stuff stuck together. And if you disturb it, it's going to sort of break into pieces. So if you've got one, if one eventually does sort of is spotted that's heading towards us, we need to know, what happens if you smash something into one of these things, whether it's a solid one or a rubble pile one. So this one that's going to be smashed into could easily be a rubble pile one. We just don't know. And yeah, it's going to be very interesting to. I want to see the images because there are two imaging systems that are going to be watching this. One on the actual impactor itself, and one on the little follow-on spacecraft that's coming after it. So it should be quite amazing to see how much of a kick this impactor gives this little moonlet of the asteroid, and how much it affects its orbit. Because the impact from the thing itself will impart some force onto the little body, but when the explosion happens, when it hits, it's going to be an explosion. Any stuff that then gets flung out is also going to, with the old equal and opposite reaction business, that's also going to impart a bit of movement to it as well. So that's what they're really interested in seeing, is how much its orbit will be changed both by the impactor and by the force of the explosion that flings stuff in one direction, and therefore the body will go in the other direction. So they don't really know yet. They've got a range of possibilities, and they call it beta or beta. It's the factor that they want to measure, and could change it a little bit. It could change it a lot.
It's not just the impact on the moonlet itself. It's also how the centre of gravity changes and how that would affect the primary body, the one that's not being hit. Didymos.
Yeah, that's right, because we tend to think of one thing orbiting another thing, but really it's when you've got two things, they are actually orbiting around a common centre of gravity.
The centre of gravity is called the Barry Centre. And that
the Barry Centre, yeah.
A 1970s dude wearing a safari suit.
Barry Centre, wearing his safari suit and his body shirt. Anyway, Barry Centre, yes, so that's the centre of gravity around which two objects will orbit. And so for the Earth and the Moon, the Barry Centre, if I remember correctly, is actually inside the... Is it inside or outside the Earth's surface?
Inside the Earth.
Just inside, isn't it?
Just inside. Yeah. Otherwise, the Earth and Moon would be a binary system.
Who would want that?
Like Pluto and Charon. And apparently it is Charon. I've spoken to a lot of astronomers about it, and they all call it Charon. None of them call it Chiron.
So Sharon's got a Barry Centre.
So Sharon...
What's Sharon?
Think of anything more Australian, can you? Sharon and Barry.
Sharon. Sounds like Sharon, and she's got some sort of dog called Pluto or something. And they're made Barry Centre, yeah.
Didymos and Dimorphos will make their closest approach to Earth in years at the time of the impact, passing just 10.8 million kilometres from the planet. In October, scientists will use ground-based telescopes around the world to look for key events and calculate Dimorphos's new orbit, expecting that the time it takes the smaller asteroid to orbit Didymos will have shifted by several minutes. These observations will also help constrain several theories that astronomers currently have about Dimorphos's orbital dynamics and the rotation of both asteroids. Now, a short time ago, a 6-unit Italian space agency CubeSat was deployed from the DART spacecraft. The light Italian CubeSat for imaging asteroids, or Lucia Cube, is designed to monitor the impact and then collect data. Lucia Cube will be followed in 5 years' time by the European Space Agency's Hera mission, which will launch in 2024 and arrive at Dimorphos in 2027. Hera will carry 2 6-unit CubeSats. Milani will study the binary's composition, and Juventus will attempt a landing on Dimorphos. This report from ESA TV.
The incredible adventures of the Hera mission. Asteroid on collision course with Earth. Imagine the headlines. It may sound like science fiction, but to date we've discovered more than 20,000 asteroids whose orbits bring them dangerously close to Earth. It's a hazard the dinosaurs were powerless to stop. With all the advanced science and technology in our hands, could we do better? Planetary defense requires planetary cooperation. Meet the Hera mission, led by the European Space Agency, set to rendezvous with a binary asteroid system in 2026. Didymos is orbited by a smaller asteroid, Dimorphos. This pair poses us no risk, but our experiments with them will be key to keeping Earth safe. Dimorphos is a small asteroid, yet a rock of its size could devastate a small country or large metropolitan area. Studying asteroids like this from Earth is challenging. As a matter of fact, today we still know very little about their physical properties. The only way to capture their secrets is to go and visit, so we need Hera to get up close and personal. When Hera reaches it, Dimorphos will already have been impacted by NASA's Double Asteroid Redirection Test, or DART for short. This cosmic shove is expected to slightly shift the orbit of the asteroid moon. Hera will examine the crater left by DART, the composition of Dimorphos, map its surface temperature, and probe its internal structure, similarly to an X-ray. Meanwhile, Hera will deploy 2 briefcase-sized CubeSats called Juventus and Milani. Packed with high-tech equipment such as a low-frequency radar, a mineral mapper, dust analyzer, and a gravimeter, these mini-satellites will get an even closer look before attempting to land. Altogether, the DART impact and Hera's data will let us understand whether this technique can be used in the future to deflect an asteroid on a collision course with Earth, like an astronomical game of billiards. In addition to Hera's main planetary defense quest, the mission will gather invaluable bonus science. New understanding of collision physics and crater creation could revolutionize our understanding about how the solar system was formed. Hera will even test new techniques for autonomous deep space navigation and guidance, while working in the asteroid's extremely low gravity. This will help pave the way for future interplanetary missions. Not bad for a space probe the size of an office desk.
The DART mission follows on from the 2005 Deep Impact mission, which slammed an impactor into the comet Tempel 1. The impactor successfully collided with the comet's nucleus, forming a 100-metre wide crater that was some 30 metres deep, excavating debris from the cometary interior. Images taken by the Deep Impact spacecraft showed the comet to be more dusty and less icy than had been expected. In fact, the impact generated an unexpectedly large and bright dust cloud, initially obscuring the view of the impact crater. X-ray observations showed the comet continued outgassing from the impact for 13 Earth days, with a peak 5 days after impact. A total of 5 million kilograms of water and between 10 and 25 million kilograms of dust were ejected by the impact. Astronomers described the debris as being as fine as talcum powder rather than sand. Spectroscopy readings of the debris cloud detected water ice, clays, carbonates, sodium, and crystalline silicates. Observations also revealed that the comet was porous, about 75% empty space, very similar to a fresh snowbank. This is SpaceTime. Still to come. A new study shows continental plate movements control Earth's largest volcanic events, and SpaceX launching more and more Starlink satellites. All that and more still to come on SpaceTime. A new study has found a surprising link between the slowing of continental plate movements and the timing of Earth's largest volcanic events. The findings, reported in the journal Science Advances, sheds new light on the timing and likely cause of major volcanic events that occurred millions of years ago and caused such climatic and biological upheaval that they drove some of the most devastating mass extinction events in the planet's history. Earth's history has been marked by major volcanic events, known as large igneous provinces. Using chemical data from ancient mudstone deposits, obtained from a 1.5 kilometre deep borehole in Wales, scientists were able to link two key events from around 183 million years ago during the Torsian period. Scientists found that this time period, which was characterised by some of the most severe climatic and environmental changes in Earth's history, directly coincided with major volcanic activity and its associated greenhouse gas release on the southern hemisphere, in what is now southern Africa, Antarctica and Australia. Tectonic plate reconstruction models showed that these are the key fundamental geological processes that control the timing of this volcanic event, as well as others of similar great magnitude. The study's lead author, Misha Rule, from the Trinity School of Natural Sciences, says researchers had long thought that the onset of upwelling of molten volcanic rock or magma from deep in the Earth's interior as mantle plumes triggered this volcanic activity. But the new evidence shows that the normal rate of continental plate movements of just a few centimetres per year effectively prevents magma from penetrating the Earth's continental crust. It seems it's only when the speed of continental plate movement slows down to near zero that magmas from mantle plumes can effectively melt their way up through the crust to the surface, causing major large igneous province volcanic eruptions and their associated climatic perturbations and mass extinction events. Crucially, further assessment shows that a reduction in continental plate movements likely controlled the onset and duration of many of the major volcanic events throughout Earth's history, making it a fundamental process in controlling the evolution of climate and life on Earth's surface throughout the history of the planet. This is SpaceTime. Still to come, SpaceX says even though it's requested authorization to launch some 42,000 Starlink satellites, it probably won't need that many after all. And later in the science report, do you suffer from doom-scrolling addiction? Well, if you listen to us, you probably do. All that and more still to come on SpaceTime. SpaceX says even though it's requested authorization to launch some 42,000 Starlink broadband satellites, it probably won't need that many to achieve the global internet coverage it's seeking. The sheer number of satellites launched, which as of September 11 this year stood at 3,293 spacecraft, is posing a serious problem for astronomers trying to undertake important scientific research. There are also growing concerns for the safety of space navigation because of the increasing congestion being caused by this massive number of satellites. And Starlink satellites are also getting bigger. The first batch had a mass of just 227 kilograms. The current versions weigh in at some 260 kilograms, and the next variant on the production line come in at around 300 kilograms each. But as they're increasing in mass, they're also increasing in capacity with bigger antenna and better technology. And SpaceX says that should mean that less will be needed to achieve the same level of service. Still, so far, the launch rates aren't showing any signs of decreasing. SpaceX have already undertaken more rocket launches this year than anyone else. That includes China, which is engaging in a massive military build-up. In fact, just recently, SpaceX launched another 34 Starlink satellites aboard its Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center in Florida. Also on board was AST SpaceMobile's experimental Blue Walker spacecraft. It's described as the largest commercial communications array ever flown in space. Blue Walker 3 is actually a test satellite designed to help develop the first space-based cellular broadband 4G/5G network, which will be accessible by standard smartphones for everyday usage rather than just for emergency messaging. AST SpaceMobile has partnered with 25 cellular service providers. The satellite, which is now unfurling its giant 64-square-metre array, will undertake 6 months of testing with 10 cell phone companies on 6 continents. The launch went smoothly, with the Falcon 9 core stage used for the mission undertaking a record-breaking 14th liftoff. The core stage then successfully returned to Earth, landing on the drone ship a short full of gravitas, which had been pre-positioned downrange in the North Atlantic Ocean. Just a few days earlier, another 51 Starlink satellites, together with an orbital transfer vehicle, were launched aboard another Falcon 9 from the neighbouring Space Launch Complex 40 at Cape Canaveral. The orbital transfer vehicle, named Sherpa LTC and operated by a company called Spaceflight, then delivered an undisclosed payload into another orbit before being deployed. Spaceflight describes Sherpa as a mothership for small satellites that allows them to ride-share and reduce their launch costs. Just over 8 minutes after launch, the Falcon 9 core stage returned to Earth, landing on the drone ship Just Read the Instructions, which had also been pre-positioned downrange in the North Atlantic Ocean. The latest spate of Starlink launches began with the deployment of 53 satellites from Cape Canaveral, with the Falcon 9 core stage again landing on the drone ship a short full of gravitas. Meanwhile, China have launched more spy satellites, with another pair being sent into orbit as part of what President Xi Jinping and the Chinese Communist government refer to as preparations for war. The Yogon 3302 spacecraft were launched aboard a Long March 4C rocket from the Jiuquan Satellite Launch Center in northwestern China's Gobi Desert. Beijing claim the spacecraft will be used to monitor land use, crop yields, urban planning, and take care of natural disasters. However, military analysts say the Yogon are pure and simple military spy satellites, equipped with high-resolution optical and synthetic aperture radar imagery systems and electronic signals intelligence gathering technology designed to provide continuous surveillance and reconnaissance monitoring of areas of interest to China. As well as the launch vehicle's upper stage, the United States Space Force says it detected 2 new objects in orbit following the launch, travelling in a 688 by 680 kilometre high near-polar orbit. The flight follows the earlier launch of a Kuaizhou 1A rocket, also from Jiuquan, carrying the SentrySpace 1S3 and S4 experimental satellites into orbit. Beijing claims these 2 spacecraft will test out new navigation system technologies. And just hours later, Beijing launched another Long March 2D rocket, this one from the Zhaichang Satellite Launch Center in southwestern China's Sichuan province, carrying 3 more Yogang 35 spy satellites. Beijing's also placed a new Zhongjing 1E military telecommunications satellite into orbit. The 5,320-kilogram spacecraft was launched aboard a Long March 7A rocket from the Wenchang Satellite Launch Center on Henan Island in the South China Sea. Based on a DFH-4 satellite bus, the spacecraft is equipped with C, Ku, Ka and L-band transponders and is carrying enough fuel for a design service life of 15 years. China now has an estimated 539 satellites orbiting the Earth, including some 217 Earth observation, surveillance and reconnaissance satellites, which include some 41 Gofeng and 103 Yaogang spy satellites. This is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.